Let us talk about wave-particle duality today. Universe presents herself as matter and energy. In quantum mechanics or quantum physics, particle or quantum exists as particle and energy. So, what is this wave-particle duality? See, let me start with energy. You know, light is a form of energy, it is purely electromagnetic wave. See, some of the properties of light, like interference, polarization, are explained by using the wave theory of light. That means energy exists as wave, light is a wave. But at the same time, another phenomenon of light, that is photoelectric effect, is explained by using the particle nature of light by Albert Einstein. Albert Einstein used Max Planck's quantum theory to explain the photoelectric effect. So from this we understood light, that means energy, exists as wave and particle. Now we come to matter. See, matter, we know it is atom, it consists of atoms or particles, it consists of molecules, electrons, we know that. But de Broglie come up with a theory like each particle, for example, especially atom in the particles in the atomic level is associated with waves. Even larger particles are having waves, their frequency is very less, so we cannot detect those waves. That's what he is telling. So de Broglie's principle is this: material particles like electrons, protons, atoms, they are associated with waves, and these waves are known as matter waves, and the wavelength of these waves he call it as the de Broglie wavelength. And one important mathematical equation here we can tell is that from the second postulate of Bohr's atom model, you know, it is the second postulate is the angular momentum is an integral multiple of h by 2 pi. MVR is equal to NH by 2 pi. See, from de Broglie's hypothesis as well, we will be getting the same equation. See, from the de Broglie's equation, he combined these two equations. See, the equations, you can see it in the subtitles, it's there. No need to worry. You know, E is equal to h nu. Energy of one photon is equal to h nu. And from Einstein's mass energy relation, you know that E is equal to mc square. Combining these two equations, h nu is equal to mc square. H nu you will substitute c by lambda, right? Because velocity is equal to frequency into wavelength. hc by lambda is equal to mc square. C and C got cancelled, and you will get h by lambda is equal to mc. From that, you can get the de Broglie wavelength. Lambda is equal to h by p. mc means momentum, mass into velocity, h by p. This equation, see, when these electrons, we can use it again. When these electrons revolve around the nucleus, the circumference of the orbit is 2 pi r. If r is the radius of the orbit, 2 pi r will be a multiple of wavelength of these matter waves, right? So you can write integral multiple of the wavelength. So you can write 2 pi r is equal to n lambda. Okay. Again, you can substitute lambda as h by momentum h by p. That means 2 pi r is equal to n into h by mv. When you cross multiply and rearrange, you will get mvr is equal to nh by 2 pi. So the concept of stationary orbit is correct. That's what de Broglie is also suggesting. That means there is definitely the existence of matter waves. So from this we understood particle. It is having, that means matter is having particle nature, and at the same time it's having wave nature as well. Those waves we call it as de Broglie waves. So that's all about duality, that is wave particle duality. And see to the experiments. See, I will give the link in the description. See how we proved this electrons are having experimental proof. See, we understood that electrons from the de Broglie's concept, de Broglie's theory, we understood that electrons or protons or the particles in the atomic level behave as waves. But the experimental proof and its impact, see, I think in 2010 or before that, you might have studied Young's double slit experiment in light. In Young's double slit experiment, we pass light to get interference and all these aspects. We pass light energy to get the interference patterns. Instead of light, if you pass electrons, what you could see is even these electrons produce interference in the screen. That means electrons act as waves. And there is some peculiar behavior, there is some observer effect. We call it as observer effect. In quantum mechanics, it is known as observer effect. Is shown by the electrons. Sometimes the electrons will be present in one position and next time it won't be present. When the observer, we used a detector to observe the electrons. When the detector is present, electron behaves in a particular manner, and if the detector is not there, the behavior of the electron is changing. That Young's double slit experiment with electrons, I have a separate video. I will give the link in the description. Those are all very interesting things to know about quantum physics and the peculiar behavior of the particles in the atomic level. It's like it's uncertain and it's like a magic. You can watch those videos as well about wave particle duality. That's all. The summary is, see, nature or the universe exists in two forms. One is matter and the second one is energy. Okay, see, matter exists as particles, but de Broglie come up with a theory. Matter is material particles like electrons or protons are associated with waves. That means matter has the dual nature. That means matter is existing in both particle and wave. And at the same time, energy, that is electromagnetic waves, light, we know it's what we understood is those are all waves, electromagnetic waves. But to explain the photoelectric effect, we need to use the Max Planck's quantum theory. From that we understood energy. That means the light energy exists both as particle and wave. So that's the summary. That is the wave particle duality. Thanks for watching. Yeah, thank you.